For the rest of this unit, we're going to be focused on the segment relationships in circles. So instead of solving for the angle measures and the arc measures, we're going to be focused on finding the lengths of the actual segments. So there are 4 formulas that you're going to need to have, and we're going to go over the first one in this video. Alright, so we're going to be talking about finding the lengths of chords when we have intersecting chords. We're going to move on to secants and tangents in the next videos, but for right now we're going to be focused on pictures that look like this when we have 2 intersecting chords. When we have 2 chords that are intersecting, we can see that we have these divided up into 2 different parts. And so when I have that, I have a part here that's A and a part here that's B. And then I have a part here that's C and a part here that's D. So for this, in order to find the relationship that exists here, is A times B is equal to C times D. So we can say that the part times part is equal to the part times part. And we can't jump, though. We can't jump off to different chords. We have to stay on the same chord. So I can only say A times B is equal to C times D. I can't say A times D or A times C. I have to stay on that same line. So let's do a couple of examples. So looking right here, I can see that I have 2 chords. So I have this part, and then I have this part, and then I have this chord that's divided up into these 2 parts. So when I work these out, I know that I have part times part is equal to part times part. Well, the first part here is I have 9 times 2 is equal to 6 times x. And then I can just solve it from there. And this is a simple equation at this point. 9 times 2 is equal to 18. And then we have 6x. We divide by 6. And then we can see that 3 is equal to x. So the algebra part is easy. We know how to solve those types of equations. The challenge, or the geometry standard, really is focused on understanding the relationships between these 2 chords. Let's look at this example. Again, the first thing I'm going to do is identify the 2 different parts. So I have this part and this part, and then I have this one and this one. So I can now just match them up. So again, I have part times part is equal to part times part. So I look at the yellow and I can see that I have 3 times 2 is equal to 6 times x. So we have 6 is equal to 6x, therefore 1 is equal to x. Now I understand that these equations are simple and typically they will be pretty straightforward with these types of problems. Again, the thing that I really want you to take away from this is understanding how to look at this picture, see the intersecting chords, and then be able to set up that equation with the correct formula. So if I have intersecting chords, if I have a plus sign essentially in a circle somewhere, then, and I'm looking for a segment length, not the arc, not the angle, but a segment length. So if I'm looking at x, I can see I want the length of that. That's when I know to use this formula. Now this one looks a little more daunting just because we have 4 binomials here. But again, we're going to solve it the same way. So I'm just going to highlight this part and this part so I know that I have those 2. And then this chord here has this part x plus 2 and this part x plus 3. So when I set this up, I'm still going to use the same formula. I'm still going to say part times part is equal to part times part. And then I'm going to say, okay, well I got x plus 1 times x plus 5 is equal to x plus 2 times x plus 3. Now this can be a little, I can understand why this would seem a little bit more intimidating of an equation. But what we're going to do here is we're just going to distribute. So we're just going to say x times x, and then we would end up with x squared. Then we're going to say plus, well, x times 5 is 5x, plus, well, now we have to multiply 1 times x, so we have x plus, and then 1 times 5 is just 5, is equal to, and we have the same thing, so I'm just going to copy and paste that there. So we have x times x, which is x squared, x times 3, which is 3x. Sorry, I forgot to take off that. Okay, so x times 3 is 3x. And then we have to multiply out the second term. So we have 2 times x. And then we have 2 times 3. Now we can clean this up a little bit by combining like terms. So I'm just going to copy and paste this down. And again, I'm just doing this just because it's going to save a little bit of time. And I can see that 5x plus x is really just 6x. And I can see that 3x plus 2x is just 5x. Now I can start combining like terms. The first thing I'm going to do is I'm going to subtract x squared from both sides, and when I do that, they go away because x squared minus x squared is 0, and x squared minus x squared is 0. So I'm left with 6x plus 5 is equal to 5x plus 6. This is a little bit less intimidating. So I subtract 5x from both sides, and we get x plus 5 is equal to 6. And then we can subtract 5 from both sides, and we get x is equal to 1. Okay? So, again, it's a little messier in the sense of it takes a little bit longer algebraically to solve it, but the process is still the same. We have part times part is equal to part times part. Okay, well, that is it for this video. I will do intersecting secants in the next one. Thank you.